Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at securing networks with firewalls. We'll be discussing firewalls, the types of firewalls, packet filtering firewalls and the benefits and limitations, and then finally we're going to look at stateful firewalls and their benefits and limitations. This episode is part of my series on network security. I'm Kevin here at KevTechify. Let's get this adventure started. All firewalls share some common properties. Firewalls are resistant to network attacks. Firewalls are also the only transit point between your internal corporate network and external network because all traffic flows through that firewall. And then finally, firewalls enforce the access control policy. What you're allowing in and out of your network, what traffic you're going to allow to certain destinations or that originated at certain destinations. There are a couple different types of firewalls, and each of those different types have benefits and limitations. Here are some examples on how you could set up your firewall to protect your network. First thing here is you have to have allow statements and you have to have deny statements. Some examples of what you could allow here is the first one here: allow traffic from any external address to get into the web server. You're hosting your own web server. It's an e-commerce site. Your customers need to come there and put orders in. Your business partners need to update information about when shipments will arrive if you're like a manufacturing company. Allow access traffic here to your FTP server. Once again, maybe you're sharing out some files with your customers or your business partners that they need to get some information from you. We're going to allow SNMTP traffic, simple mail transfer protocol. We're going to allow mail to come into our network from the outside. We're hosting our own internal email server, and so we have to let that traffic come in through the firewall. And then allow traffic to internal IMAP server. IMAP is another way to check your email, so once we're allowing that IMAP traffic to come into our network. Then we have deny statements. Here we're going to deny all inbound traffic with internal IP addresses. So any traffic on the outside that has our internal addresses, we're going to deny that because all traffic with internal addresses should start on the inside and not have to go all the way through our firewall. The next one here: deny all outbound traffic to server from external addresses. So deny all inbound traffic to one of our servers from external addresses. We don't want our servers to be directly accessible on the internet. Deny all inbound ICMP echo request traffic. We don't want people to ping our internal devices to figure out what our network looks like and what devices we could have, and do a ping sweep and then do a port scan on it. That just introduces vulnerability. So let's deny all those ICMP, all those ping echo requests. Then we'll deny all inbound Active Directory requests. If you're using Active Directory, you should be internal to your company, and nobody from the outside should be connecting into your Active Directory. Now, if you do have people out on the road, salespeople, management working from their home offices, that's where you'd use a VPN. But there should be no outbound or inbound Active Directory traffic from the internet coming into your company. Deny all inbound traffic to our SQL servers. The SQL servers are feeding internal processes. They shouldn't be accessible from the outside. And then also deny all Microsoft domain local broadcasts. Microsoft and their domain and Active Directory, they send out local broadcasts on your local area network, your internal network. Those should not originate from the outside, so you should deny those. Here we have a little graphic down here, and a lot of times what you'll see is the outside world here, all these requests are being bounced back. Now, not necessarily bounced back, they're just being deleted. But you want some traffic to come in. Remember, we had on the left side, we had 4 allow statements. What we typically talk about is punching a hole in the firewall. We punch this hole Here's the hole, and that hole is set up for one of these allow statements to go through our firewall. So a lot of times you'll hear people say, yeah, we need to punch a hole in the firewall for this process. And what this is request originating, starting on the outside, destined for the inside of our network. If you like this episode on securing networks with firewalls and you get value out of it, and depending upon the platform you're using, please click that like button, give a 5-star rating, leave a comment. Doing this supports the channel, which in turn helps me bring you more great content. Subscribe to my channel and click that notification bell to be alerted every time I release a new episode. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. It's important to understand the different types of firewalls and what their capabilities are, so that way you get to use the right firewall in the right situation. There are basically 4 types of firewalls here. The first one we have here is packet filtering, or it's also known as a stateless firewall. These are usually part of a router firewall. So they install on your router, and then it either permits or denies traffic based on layer 3 or layer 4 information. IP addresses, layer 4 logical port numbers, HTTP port 80. They are stateless firewalls that use a simple policy table lookup that filters traffic based on specific criteria. So it gets the traffic in, looks at the table. Do we deny? Do we permit it to go through? The second type of firewall here is the stateful firewall. These are the most versatile and most common firewall technologies in use. Stateful firewalls provide stateful packet filtering by using connection information maintained in a state table. Stateful filtering here is a firewall architecture at that network layer in the OSI model. It creates a connection. So it uses the state of the connection, it looks at that information, and then it allows or permits and denies information to pass through depending upon the rules you have set up. The third one here is an application gateway. A lot of times people call these proxy firewalls. What these do is filter information at layers 3, 4, 5, and 7 of the OSI model. Most of the firewall control and filtering is done in software. Now, when a client needs to access a remote server, it connects to that proxy server. And the proxy server has those rules of permit and deny set up on them. And finally, we have our next generation firewalls. These go beyond the stateful firewalls by providing integrated intrusion prevention, application awareness and control, upgrade paths to include future information feeds, and finally, techniques to address evolving security threats. When we talk about packet filtering firewalls, once again, we're looking at layers 3 and 4 of the OSI model, the network layer, the transport layer. And what these firewalls can do is they can look at a number of criteria, and then based upon that criteria and what you have set up as a permit or deny statement, either let that traffic go through or delete that traffic. The criteria we can look at here is both the source and destination IP address. So we can look at where is it coming from, where is it going to. If you have a location that is maybe sending you cyber attacks, you could block that location or that block of IP addresses. Destination IP address is where that information is going. You want to block information from going to a certain destination. Then you can specify what protocol you're blocking on. What we're talking here is TCP, UDP, ICMP. Then the next thing you can specify and filter on is source port number and destination port number. This is that layer 4 logical port number. HTTP is port 80. And then finally, last thing you can look at here is the synchronize or start packet receipt. You can filter based upon that. Packet filtering firewalls have several benefits. First, they implement simple permit or deny rule sets. Next, They have low impact on network performance. They are easy to implement, and they typically are supported by most of the routers out there. Next, they provide an initial degree of security at your network layer, layer 3 in the OSI model. And finally, they perform many of the tasks of a high-end firewall at a much lower cost. On the other side of the coin, packet filtering firewalls do have some limitations. They are susceptible to IP spoofing. They do not reliably filter fragmented packets. So if your packets are fragmented, they could get through that firewall. Yes, they do implement simple rule sets, but because those rule sets are simple, each of those access control entries in your access control list, you have to have a lot of lines in there, and those ACLs can become very complex. And once you have a very complex one, and what I mean by complex is 20, 30, 40, 100 access control entries in one access control list, they become very difficult to implement and then maintain those as you work through them. They cannot dynamically filter certain services. And finally, they are a stateless firewall. When we take a look at stateful firewalls, they also have some benefits and limitations. Now, the benefits here for stateful firewalls, first one here is it's typically a primary means of defense on your network. The second here is it's got strong packet filtering. It can look at those packets. It can do some analyzing. It looks at source and destination, and it can make decisions based on different criteria. Third one here is improved performance over packet filters. If you compare hardware to hardware, when you do stateful firewalls, you will get better performance than if you did a stateless firewall. Defends against spoofing attacks and denial of service attacks. Once again, remember, stateless is susceptible to IP spoofing. Here stateful, once again, stateful, it can defend against IP spoofing attacks. And finally, another benefit here is it's got a richer data log. It logs a lot more information because it can filter on a lot more information. It has access to that, so we can log that information. Of course, there are limitations. And some of the limitations we have is there's no application layer inspection. There is no, in the OSI model at the application layer, we can't see what's going on here when we use stateful firewalls. We have limited tracking of stateless protocols. Next, difficult to defend against dynamic port negotiation. Some protocols dynamically negotiate ports, and a stateful firewall does have some problems defending against that. And finally, for a stateful firewall, there is no authentication. It was my pleasure to provide you with this wonderful episode on securing networks with firewalls. If you like this episode and you get value out of it, and depending upon the platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com, and you can get all these episodes in video and podcast form. In the upper right is my playlist for my series on network security. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode on my series of network security. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.